Hello students, Assalamu alaikum. Hope you are fine. We are going to have another class on geometrical optics today. I welcome you to my tutorial that is Jaffar's tutorial and presented by Muhammad Jafar Iqbal, Assistant Professor of Physics, Rajakutar English Medium Morning Shift, Rajakutar Model College. That is the topic, chapter Geometrical Optics of Physics of class 12. Today we will discuss how the magnification occurs in compound microscope. Let us see the figure here. Here we will explain how the magnification occurs and the expression for the magnification in compound microscope. In compound microscope there are two lenses. One is objective and another one is eye lens. This is which is known as eyepiece. Here the focal length of the objective is f0, and the focal length of the eyepiece is Fe. That is, Fe is the principal focal. That is this one is the focal length. Okay. Here, the object is placed in front of the objective beyond its principal focus. Here, PQ is the objective. PQ is the objective. So, with the help of ray diagram, we see there that is P1, Q1 is the image of this object PQ. Here, this image P1, Q1 is in between the optical center and the principal focus of the eyepiece, and this object P1, Q1 will act as this image P1, Q1 will act as the object in case of eyepiece. Here, let us see how the image is formed. One ray parallel to principal axis and passing to the principal focus of the eyepiece, and these two rays are coming here and these are the refracted rays. So if we produce this, since these rays are diverging, so these rays will not be behind the lens. So if we produce the rays, then they will meet at point, that is at point P2. And if we draw the perpendicular on the principal axis, then here P2 Q2 is the virtual image of the object, that is PQ. This is the final image and the final extended image. Okay, this image is virtual, inverted and magnified. So let us see the expression for the magnification in this case. Here the magnification, that is M. Magnification is M. That is, magnification is equal to the length of the image, that is final image P2 Q2 divided by length of the object, that is initial object, that is PQ here. Okay. So P2 Q2 by PQ is equal to P2 Q2, and we can write P1 Q1 into P1 Q1 by PQ. Here P1 Q1 by PQ is the magnification, is at the objective, and P2 Q2 by P1 Q1 is the magnification in the eyepiece. So M is equal to small m1 into small m2, that is equation number 1. Let us see here, that is the distance of the object PQ, that is E1. So E1 distance of the object PQ from the objective, V1 distance of the image P1 Q1 from the objective, that is this distance of the distance of P1 Q1 from this objective, that is V1. Okay. F0, focal length of the objective F0, that is this distance, that is F0, focal length of the objective. Q2, distance of P1 Q1 from the eyepiece, that is this distance. Okay, that is Q2, and V2, distance of P2 Q2 from the eyepiece, that is this distance, that is the distance of P2 Q2 from the eyepiece. Fe, the focal length of the eyepiece, that is this distance from this point, this Fe, that is the distance, that is the focal length of eyepiece. From the general equation for length we get for the objective, that is 1 upon V1 plus 1 upon E1 is equal to 1 upon F0, or 1 plus V1 by E1 is equal to V0 by F0. If we multiply both sides by V1, then we get this one, or minus V1 by E1 is equal to 1 minus V1 by F0. Okay, but we know magnification m is equal to minus v1 by e1. Therefore m1 is equal to 1 minus v1 by f naught. That is equation number 2. That is, this is m1, so m1 is equal to 1 minus v1 by f naught. That is equation number 2. Similarly, for eyepiece, that is m2 is equal to minus v2 by u2. That is equal to 1 minus v2 by f, equation number 3. Now from equation 1, 2 and 3 we get m is equal to, that is the value of m1, 1 minus v1 by f naught, that is m2, that is 1 minus v2 by f3. Again m is equal to m1 into m2 is equal to, then minus m1 is equal to minus v1 by e1 into m2 is equal to minus v2 by u2, or m is equal to minus v1 by e1 into 1 minus v2 by fe. Okay, this one 1 minus v2 by fe. But for virtual image, v2 is negative. Therefore m is equal to minus v1 by e1 into 1 plus v2 by fe. And we know that the final image is formed in case of this compound microscope. The final image is formed at the least distance of distinction, and that is d. That is capital D. So instead of v2 we can use d. Instead of v2 we can use d. So m is equal to minus v1 by e1 into 1 plus d by fe is equal to equation 4. That is equation number 4, and this equation 4 is the expression for magnification in compound microscope. So I hope you understood the magnification in compound microscope. Let us go for next topic, that is, you can see a figure here, that is, this is astronomical telescope. In astronomical telescope, basically 3 portions, that is tube. Okay, this one is objective, here objective, and this one is the eyepiece, and this one, the small one, that is the viewfinder, that it helps to find the objective at the long distance. Then we focus on the object with the help of this telescope, and that's why this is known as viewfinder. Let us see the ray diagram and magnification in astronomical telescope. In astronomical telescope, there are 2 focusings here. There are 2 focusing. One is normal focusing, another one focusing for distinct vision. So here the rays are coming from infinity, because the object is infinity and the object will be very big. The objects are coming parallel. The rays are coming parallel to each other, but not parallel to principal axis. So the rays are coming and they are forming the image is formed at the principal focus of this objective lens. Here we see that is the f naught is the principal focus of the objective, and fe is the principal focus of the eyepiece, and both the principal foci lie on the same point. They are at the same point. That's why from the C1, this one, that is the f naught, and from C2, that this point, that is fe. Okay, and the image here, the rays are meeting here. This is the object. This is the object is the principal focus of the eyepiece. So the image will be formed at infinity. Here the image will be formed at infinity. It will be very big but not clear. It will be blurred. That is the first condition we will have. This is normal focusing. That is, we are getting the object within our view. In this case, magnification for normal focusing, m is equal to angle produced by the image at the eye, that is beta. Okay. This angle that is beta, and angle produced by the object at the eye, that is alpha. This one is alpha. Okay. So here that is beta by alpha. Since beta and alpha are very small angle, that's why we can write beta is equal to tan beta and alpha is equal to tan alpha. So therefore m is equal to beta by alpha is equal to tan beta by tan alpha, and from this figure we say tan beta is equal to b prime f naught by c2 f naught into c1 f naught by b prime f naught. Okay, they are cancelling. These two cancel each other. Therefore m is equal to f naught by fe, that is c1 f naught by c2 f naught, that is fe by f naught. This is the magnification for normal focusing. magnification for distinct vision. Okay, let us see here. In this case, these eyepiece is taken closer. These eyepiece is taken closer to the objective. That's why these image will be in between the optical center and principal focus of the eyepiece. That's why here we will have an image, inverted image and virtual image. Okay, and here we can see the object clearly. That is, we are getting the clear vision, and that's why it is known as distinct vision. Focusing for distinct vision. In this case, magnification m is equal to beta by alpha is equal to tan beta by tan alpha. That is, this one is beta and this one is alpha. So tan beta by tan alpha, that is a prime b prime by e b prime into, if we look at the figure, these two triangle, this triangle and these two triangle. So a prime b prime by e b prime into o b prime by a b prime. That is, o b prime by e b prime is equal to f naught by e b prime. Okay. Now for the eyepiece, lens a prime b prime is the object and a double prime b double prime is the image. Here a prime b prime is the, for the eyepiece, a prime b prime is the object and a double prime b double prime is the image. So from the equation of lens we get 1 upon e b double prime plus 1 upon e b prime is equal to 1 upon f a, or 1 by minus d, because e b prime is equal to least distance of distinct vision and it is negative. So 1 by minus d plus 1 by e b prime is equal to 1 upon f a. So therefore f naught by e b prime is equal to f naught by f e plus f naught by d. Therefore m is equal to f by e b prime is equal to f naught into 1 by d plus 1 by f a. So we get the value, that is m is equal to f naught by e b prime is equal to f naught, this one. So that is m is equal to f naught by f e into 1 plus f e by d. So we get the magnification for distinct vision. Length of the telescope for normal focusing. This is the normal focusing, we know. Length of the tube. This is the length of the tube, the distance between the two lenses. The length of the tube, it is L is equal to, that is f naught plus f e. That is the, in case of normal focusing, the length of the tube, that is L is equal to f naught plus f e. And the length of the telescope for distinct vision. Here it will be a bit different from the length of the tube in case of normal focusing. Let us see here, length of the tube L is equal to, look at this here, L is equal to this and this one, that is OB prime, that is OB prime plus EB prime, EB prime. OB prime is equal to F naught plus EB prime, but M is equal to, we know, F naught by EB prime is equal to F naught into 1 by D plus 1 by FE is equal to F naught D plus FE by D into FE. Therefore, EB prime is equal to D into FE by D plus FE. So if we, therefore L is equal to F naught plus D into FE by D plus FE. So we get the expression for length of the telescope in case of distinct vision. Okay, so today we have finished our lecture. I hope you understood the two topics, that is the magnification in compound microscope and the magnification in astronomical telescope. In the next class we will have another topic with variety. Till then, Allah Hafiz. Assalamu alaikum wa rahmatullah.